Assalamu alaikum. Welcome everyone. Thank you for joining me today. My name is Dr. Sherin Alamassi and I'm going to present today's presentation on behalf of Dr. Eman Zaitoun, Professor Imad Al-Ghazu and Professor Mohammad Alhassan. My presentation is entitled Integration of 3D Printing and Sustainability Concepts in High School Education, Preparation of Future Engineers. Our agenda of today's presentation will include the introduction of the study, literature review, the methodology of the study, the results, discussion, and conclusion. Our study focuses on understanding how ready high school teachers are to integrate two emerging concepts, 3D printing and sustainability, into their classroom, and how we can better support them. Engineering programs today, especially civil engineering, heavily rely on 3D printing and sustainability principles. However, these concepts rarely appear in K-12 classroom, which creates a gap between high school learning and university expectation. This research aims to bridge that gap by promoting awareness and supporting teachers in bridging these concepts into their teaching practices. Ultimately, integrating such modern tools prepares students for university majors and emerging STEM career. This study has the following objectives. First, to assess high school teachers' knowledge and awareness of 3D printing and sustainability. Second, to understand their attitudes toward integrating these concepts into education. Third, to identify perceived challenges and barriers. And finally, to explore their professional development needs. Moving through literature review, 3D printing in education has rapidly expanded into K-12 classroom. Research has shown that it increases student engagement and supports hand-on learning. For example, some research found that 3D printing enhances design thinking and allows students to visualize complex concepts more easily. Similarly, reported that teachers using 3D printing observed improved student creativity and deeper understanding of STEM topics. These findings highlight its potential as powerful educational tools. Sustainability education in K-12 has also become a global priority. For example, UNESCO 2017 framework encourages embedding sustainability concepts across all levels of education. Research found that sustainability teaching helps students develop critical thinking, system thinking, and responsible decision making. Incorporating sustainability early builds environmental awareness and prepares students to address current and future global challenges. The connection between 3D printing and sustainability is increasingly recognized in engineering education. 3D printing promotes material efficiency, encourages low waste manufacturing, and supports exploration of sustainable product design. Studies shown that using recycled plastic filament in 3D printing can significantly reduce environmental impact. By combining these subjects, teachers can help students understand real-world application of sustainable engineering. Despite its benefits, several barriers limit integration of 3D printing in school. Study found that teachers often struggle with limited training, minimal technical support, and difficulties in aligning 3D printing activities with the curriculum. Additionally, schools may lack access to printer materials and times for hand-on projects. Understanding these barriers is essential for designing effective support systems. Regarding the study design, this study employed a quantitative descriptive survey-based research design. A structured questionnaire was developed using Google Forms to ensure accessibility, ease of distribution, and efficient data collection. The survey link was distributed electronically to sample of in-service and pre-service teachers across multiple schools, including those enrolled in a postgraduate professional diploma in teaching in Al Ain University. The instrument consisted of items measuring four domains: teacher knowledge of 3D printing and sustainability, attitude toward integrating 3D printing in education, perceived barriers to implementation, and professional development needs. Descriptive statistic analysis was conducted to interpret the collected responses and address the research question. Although the survey link was distributed multiple times through Google Forms and shared with several schools, the overall response rate remained relatively low. Several factors may explain this outcome. First, many teachers reported limited familiarity with 3D printing and its connection to sustainability, which may have caused a hesitation or a reluctance to complete the survey. This was further supported by direct feedback from school principals, who indicated that a significant number of their teachers were not aware of the topic and didn't feel knowledgeable enough to participate. Validity and reliability checks were conducted to ensure the instrument accurately captured the construct. The data was then analyzed statistically to identify significant trends that inform the study conclusion. Now let's talk about results. To answer question 1, first, we will discuss awareness and knowledge of 3D printing, analysis of the survey items related to knowledge of understanding what 3D printing is, its classroom applications, required resources, and design requirements reveal the following. Majority of teachers have low to moderate understanding of 3D printing. Only a small number have used the 3D printing in their teaching. Teachers show strong interest but lack hands-on experience. Knowledge about technical components like software, filament, safety, calibration appears to be limited. Awareness of sustainability concepts, items related to sustainability, like use of eco-friendly materials, recycling, sustainable design application. Teachers also reveals that teachers demonstrate general awareness of sustainability, especially environmental conservation and reducing waste. However, linking sustainability specifically to 3D printing, like recycled PLA sustainable design, is not yet well understood by most respondents. Comments indicate interest in using biodegradable material, but limited expertise on how to implement them. So, to conclude, teachers show moderate awareness of sustainability, low to moderate awareness of 3D printing, and limited understanding of how the two concepts connect. Overall awareness is emerging, but practical knowledge is lacking. The result of question 2. First, teacher attitudes. Across attitudes related item, teacher hold a strong positive attitude toward integrating 3D printing. They mostly believe that it enhances creativity, supports project-based learning, improves student engagement, and encouraging critical thinking. Many perceive it as valuable for future engineering pathways. Positive attitude exists despite low experience level. The barriers are perceived as acute. The highest rated barriers include technical barriers, knowledge and skill barriers, and institutional barriers. Common teacher comments: we need more training. Many responses emphasize the need for resources and professional development. In addition, teachers consistently express the need for hands-on workshop, curriculum-aligned lesson plans, technical support, and troubleshooting guidance. Also, they want structured training, resources, and ongoing support. The impact of training on teacher confidence was calculated and indicated that training is deciding factor. A untrained teacher generally disagree or are neutral about their confidence, while trained teachers strongly agree. To conclude, for result of question 2, attitudes are strongly positive, showing willingness to use 3D printing. Barriers are mostly technical and institutional, like lack of equipment, time and training. Professional developments need are high, especially hands-on skills and curriculum support. Based on the results, several recommendations are proposed. First, structured professional development program should be created that provide practical training and confidence building experience. Second, resource banks such as ready-to-use lesson plans and design files should be developed to support teachers. Also, schools need improved access to 3D printing tools, possibly through shared makerspace or partnership with university. And finally, policy support is essential. Administrators must allocate funding, time, and curricular flexibility to empower teachers. To conclude, this study shows that while teachers have positive attitude toward integrating 3D printing and sustainability, they lack knowledge, resources, and technical support. With proper professional development, accessible equipment, and supportive educational policies, these innovations can be fully integrated into K-12 classroom. Doing so will enhance STEM education and better prepare students for engineering and technology-related university majors. Thank you for attention. Do you have any question? I'll be happy to answer them. And these are some of our references.